Rigdal here with another lesson on decimals, this time multiplying decimals with area. I'm going to show you some pictures on what multiplying decimals might look like, and then we're going to do some actual paper, pencil, or in this case, tablet computer multiplying. So let's say you had a multiplication problem that looks like this. Let's say you had 3. That's not the pen I need. How about this one? Yeah, that's what I want. Okay, so let's say you had 3 and a half, 3.5, I'll make my decimal nice and big, times, let's say you had 4 and a half, or 4 and 5/10. Say you were trying to multiply those. Here's how it would look in a picture. You take a grid like I have over here, and you'd want to put your 3 and a half by 4 and a half. I shouldn't be saying it that way. 3.5, 3 and 5/10 times 4 and 5/10. Remember, area is length times width. So we have 3 and 5/10 times 4 and 5/10. And you're thinking, well, Mr. Rigdal, that's actually 5 by 5. Well, yes it is, but I'm gonna divide it up here. So let's say this way we want to go 3 and a half. So 1, 2, 3 and a half is right about there. Now let me try again. I missed. Right about there. And then this side is 4 and a half. So if we go, if we go 1, 2, 3, 4 and a half, it's right about there. Okay. Now, if I go ahead and dump in some color, I'll keep it pink for all the pink fans out there. There's 3 and a half. See that? 1, 2, 3 and a half. 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 By 4 and a half. 1, 2, 3, 4 and a half down. Okay, so now I have 3 and a half by 4 and a half all colored in. So what I'm going to do then is look at the math. I can just count these up. Let's see, I better get a different color. So here we go. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is your favorite part of watching these videos watching me count squares? I thought it might be. Okay, so we got 12 whole, right? And then we have 1, 2, 3, 4, 5, 6, 7 halves. What's 7 halves? If we count 2 at a time, we got 1 whole, 2 wholes, 3 wholes, with 1 half left over, so that's 3 and a half. And then we have this little bit here to deal with. What in the world are we going to do with this little bit? Well, it's half of half, so it's a fourth. If this was a whole square, right, then we got 1, 2, 3, 4. That's 1/4. Which in decimals, 1/4 is 2.25 or 25 hundredths, right? Because it's like 4 quarters in a dollar, 4 25s. So now counting up all these spaces, I end up with 12 and 3 wholes. And if I add those up together, I get 15 on the left side of the decimal, 5 in the ones, 1 in the tens. And then I got 5 and a 2 in the tens place, that's a 7, and a 5 in the thousandths place. 15 and 75 hundredths. 3 and 5/10 times 4 and 5/10 is 15 and 75 hundredths. Doing it using now, having this picture of a grid kind of in the back of your mind while you're multiplying is very helpful, because when you're done, you can use it to sort of estimate and see if, you know, where you want to put your decimal point. Moving your decimal point one place to the left or the right can make a difference of tens or hundreds So it's important to have an idea in your head of about what your answer should be. I'm going to do 2 different ways of paper pencil multiplication and then show you how using this picture can help me decide where to put my decimal point. So we have 4 5/10 times 3 5/10. On this one, on this side, I'm going to show you, put it down here. I'm going to do the all partials method. And over here, I'm going to do the compact method. The compact method of multiplication. But first, I'm going to do the all partials. So with all partials, you first multiply the ones. 5 times 5 is 25. Then you do this 5 times this 4, but this 4 is actually 40. So 5 times 40 is, 5 times 4 is 20. With a 0 from the 40 makes 200. So 5 times 40 is 200. Then 30 times 5, I do these 2 numbers. 30 times 5, 3 times 5 is 15. With a 0 makes a 150. And then 30 times 40, 3 times 4 is 12. And 30 has a 0, 40 has a 0, so there's 2 zeros. There's your all partials method. I've done every combination, 5 and 5, 4 and 5, 3 and 5, 3 and 4. Then I add these all up. 5, 2 plus 5 is 7, 2 plus 1 plus 2 is 5, and 1. So now, is 4 5/10 times 3 5/10 1,575? Are there 1,000 squares colored in over here? No, not even close. So I gotta estimate. Is it 1 square in 575 thousandths? No. It's going to be somewhere around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's going to be somewhere in the 15 range, right? And I know you already know it because we just did it. So does it make sense that it would be 15 75 hundredths? Yes, it does. Would it make sense to be 157 5/10? No way. So there you go. Now here's the compact method. 4 5/10 times 3 5/10. Gotta leave a little room for regrouping up top. I'll change color to do the work so you can really see it good. 5 times 5 is 25. I put down the 5, carry the 2. 5 times 4 is 20. I add the 2 for 22. Then down here I'm going to start multiplying by this 3, but since it's 30 I put a 0 placeholder. 3 times 5 is 15. I put down the 5, carry the 1. Kind of done with this 2 now. 3 times 4 is 12, plus 1 is 13. This is the algorithm for the compact method. Now I just add up these 2 numbers. See why it's called compact? I'm not going to... All partials requires a lot of vertical room. Compact, not so much. So 5 plus 0 is 5. 2 plus 5 is 7. 2 plus 3 is 5. And bring down the 1. And now, same thing. I can look over here and say, about how many squares I can think in my head. Or even if I didn't have this, let's say that this wasn't available. That's right. Get ready for some magic. Let's say it was poof, gone. And it was like, how in the world am I going to know where to put my decimal? One way to know is to just estimate in your head. 4 1/2, let's say that's 5. Round it up to 5. 3 1/2, that's about 4. 5 times 4 is 20. Which is closer to 20? 1 575 thousandths? 15 75 hundredths? 157 5/10? Only 15 75 hundredths makes sense.